Welcome to Fiberline's webinar. It is 10:30 and we will begin. This webinar is about the introduction to the GFRP for sustainable building. This is the first of many webinars to come where we will get in touch later on with the mechanical properties, with the certification, with the machining and assembly as well. For this webinar, I have prepared an agenda for you. I will present myself. I will give you a brief introduction to the composite materials, the advantages of fiberglass profiles, or more or less composite materials, the different production methods. I have taken 4 methods that I will explain in detail. You will learn more about pultrusion, what is possible, and where the limitations are. I will give a short introduction into the standards and norms that engineers can use when designing with FRP, and we will get in touch with some application areas for most common pultruded elements. At the end, we will end the webinar with the question round. So a few information about me. I have a civil engineering degree from the University of Southern Denmark, and I have been working with Fiberline for the last 5 years. And I'm responsible for the development and the maintenance of our product portfolio within building profiles. I'm married and I don't have any children. Something more private about me. Something about Fiberline. We are one of the world's largest suppliers of pultruded elements. We have 2 main business areas. The one is the wind industry, where we supply primarily carbon fiber lamellars for the increased stiffness of wind turbine blades. The second industry is our building industry, where we supply different profiles and products for the building market, primarily for structures, but also for window frames and doors as well. Fiberline is a family-owned company. It's founded in 1979 by Henrik and Dorte Thorning, and they are still the main owners of the company today. So let's dive deeper into the composite materials. I choose to call this stronger together than individually, and the composite materials are defined as materials consisting of none less than 2 different component materials, none of which are suitable for construction purposes alone, but in combination they result in very strong and rigid material. The image to the right shows the first composite materials, which date back to 11th, 12th century. This is clay brick reinforced with straws, and some of those constructions are actually still standing today. Then we jump about 500 years, and we get to reinforced concrete. In reinforced concrete, you have your steel rebars, which are primarily there to withstand the tensile forces in beams and columns and decks. And concrete is mainly suitable for compression forces as well. The reason why we reinforce concrete is because concrete is much cheaper, steel is much more expensive, and you try to optimize your steel consumptions in reinforced concretes. When we talk about composite materials today, we mainly focus on fiber reinforced plastics, where the reinforcement can be glass, carbon, or aramid, or other natural fibers, and the resins are mainly there to provide protection for the fibers, but also transfer loads between the fibers. Some of the benefits of reinforced fibers, they are normally 2 to 5 times stronger than steel in some directions. In some other directions, they are weaker than steel. Other properties that can be mentioned are significantly weight reduction. Normally, when we talk about carbon fibers, we have a density about 1.1 in comparison to, for instance, like 7.0 gram per cubic centimeters for steel. We can tailor-made mechanical properties, so we can decrease the strength locally. It's possible to predefine fracture mechanics, so meaning if you have a beam and you want to pre-design where the cracks or the deformations occur, you can predefine that as well. And it's possible to add UV protection and fire resistance to the materials as well, making it more or less usable in every single applications. Further, they have very low thermal conductivity, perfectly used for window frames and facades, and they are electrically insulating as well. Further, the manufacturing of FRP composites is very energy efficient, and a lot of end products can be easily recycled. Now we get a step deeper into the concept of composite materials. Normally we split those in two groups, liquids and dries. The first slide here is the liquids part. And here I have taken a pentagon describing cost, which is the price of the raw resin, processability. This is how easy the resin is to process in the different manufacturing methods. Then I have a rate, which is the rate of processing it. Performance is the mechanical performance, and E-code. E-code is the possibility of painting or coating the end product. This slide is only for thermoset resins. It is also possible to make the same slide for thermoplastic resins as well, like polyurethane, PVC, or polystyrene as well. Here I have listed the 4 most common resins: polyester resin, vinyl ester resin, polyurethane, and epoxy resin as well. As you can see, depending on your application area, you can choose from those 4 standard resins easily regarding and having all the 5 different parameters in the back of the mind. The next part is the dry materials. The dry materials contains of several different roving types. I have unidirectional, spoon, and mug. Unidirectional is the most common used. It gives strength and stiffness to the profile in the longitudinal direction. Spoon and mug are used primarily as cleaning for the tooling, but also to increase some of the stiffness in transverse direction. But it also gives much more space for the resin to penetrate in the deeper lying layer. Underneath, I've taken 4 different mat types. Most common is the continuous mat with random oriented fibers, and then further we have different more complex mats with wave directions of 0-90 or 0-45 or 90 degrees as well. When stacking up, you can design and tailor-make the mechanical properties that is defined by your stacking sequence of the mats. Next to the wet and dry ingredients in a common FRP product, we also have additives, and additives are defined in 3 groups. The first one is process-related additives, where I have mentioned 2 here: low-profile additives that optimize or give or stabilize the production. Primarily, a low-profile additive is there to reduce the shrinkage of the profile, and helps. And the release agent is helping to deform or release your part from your mold. Process-related additives or product-related additives. I have mentioned here 4 color pigments. The good part about FRP is the resins are liquid. You can add a color pigmentation, and your end product can be in any raw color as desired. You can also mix fire retardants to increase the fire performance of your products. UV stabilizations to increase the UV resistance as well, and then further, if needed, conductive additives can also be added to increase the conductivity. Normally, this is not used in pultrusion process. And last but not least, price reducing additives, and here chalk can be mentioned. This is mainly added to increase or decrease the overall price of the resin. When looking at the dry versus wet components, the resin is much more costly per kilo as the fiber. So by adding fillers to the resin, you decrease the price of the resin, but also in the end you decrease the mechanical and chemical performance of your parts. When you mix the dry and wet components, you have several different production methods to choose from depending on what you are trying to design. I have taken the 4 most common here. There are many more. I have taken a hand layup as the first one. And hand layup, you normally have a wooden form or even aluminum or steel form. You started by pre-sheeting the mold with release agent. This can be, for instance, silicone release agent, and then you apply a reinforcement material in predefined layers depending on the end thickness and end strength and stiffness of your component. After each layer, you spread some resin and roll it in with like here in the image, like here in the image with the paint roller. When you're finished, you can the form can be put in an oven to increase or to speed up the curing process, but it can also cure at room temperature. Curing time is dependent on your layer thickness, but also on the temperature, and it can take a few hours to several days depending. Areas of application for this can be mentioned panels for buses and trains, and components for boat industry as well. Next step is slightly bit more efficient. It's resin transfer molding, or RTM. The stacking sequence is more or less the same as by hand layup. You start by pre-sheeting the form with the release agent, and then you start stacking up your laminate. Here you can use unidirectional fibers, but also mats are commonly used. With this process, you can manufacture much larger elements. After the stacking, normally you put your element in a bag and suck the air out. And on the other hand, you are opening a valve where you actually inject the resin in your whole mold. With this process, you can manufacture wind turbine wings, for instance, and huge boat hulls as well. And this manufacturing method is much more efficient, and you have much better fiber orientation compared with the hand layout process. The next step is filament winding, very similar actually to pultrusion. Filament winding is a very effective method of manufacturing round or even squared objects. You have actually a rotating mandrel which rotates at a predefined speed, and on the other hand you have your unidirectional fibers. The unidirectional fibers are being pulled by the rotating mandrel through a resin bath. The fibers are integrated and then rotated in a very predefined stacking sequence on the mandrel. After the fibers are on the mandrel, you stop the rotation, and you can apply heat by the means of an oven, or even increasing the heat in the rotating mandrel as well to cure your end products. By this manufacturing method, you can manufacture poles, tubes for water, but also your common gas tanks are manufactured in this way. The last method, which Fiberline is very well known for, is pultrusion, and I have prepared a brand new slide for you here. This is the process, more or less. On the right, we have our dry ingredients as our reinforcement by the means of unidirectional fibers and mats. They are pulled through a preheater, where the fibers are preheated to about 50 to 60 degrees Celsius, removing the last moisture of that may be in the reinforcement. Then they are pulled through heating and curing tooling, and this tooling is normally made of stainless steel, of steel with chrome surface coating on the inside. This tooling is about 1.5 meters in length. At Fiberline, we operate with something called injection pultrusion, where we inject the resin inside the heating curing element, which we call here inside tooling. Normally, pultrusion can also be made with resin bath, where the fibers are dipped in a bathtub-like container where the fibers are then being wetted and then inserted in the tooling. With the process that we do here at Fiberline, you limit the hostile gas evaporation by having it all enclosed in one big tool. Resin injection is done primarily by pumps. The resin is injected at several different areas, here only shown at one, but normally, depending on the cross section, we can have up to 8 different injection areas. The next step is the curing. The curing is done depending again on the resin and the cross section. The temperature is about 80 to 250 degrees. And the next step is the pullers. And here we see a belt puller, but there are other means of pulling the profiles through the tooling. The whole pultrusion comes from the pulling action that is needed to pull the raw materials and resins through the die. At least we have a CNC saw which can cut the profiles, which actually moves with the profile. So we have a consistent pulling action on the whole profiles, and we don't need to stop when we're cutting the profiles. The CNC saw can cut at different angles as well, depending on the project. Some of the benefits of pultruded cross section. Cross section can reach from 1 millimeter to 1 meter in height. The image on the left is shown a small tube which is used for brain surgeries, and this tube is actually below 1 millimeter in diameter, and it's pultruded as well with glass fibers. On the right, I have taken a picture of Fiberline's biggest pultruded cross section. This is a bridge cross section which measures 225 millimeters in height, and it's about 31 kilos per meter. This cross section consists of about 3,000 unidirectional fibers. Further to that, it has about 25 different fabrics built up. The process ensures process is a continuous process with high quality compared with the other 3 production methods that have been mentioned. Regarding some standards, I have listed 3 here. The first one is a Danish standard for composite manufacturing bridges. The standard in the middle is the EN 13706, which is a standard for manufacturers of pultruded cross sections. This is very important that when looking for composite materials or pultruded cross sections, that the manufacturers stated that they are manufactured according to EN 13706. And the last one is the prospect for new guidance of the design of FRP structures. This is the preliminary Eurocode. We expect the Eurocode to be released in about 1.5 to 2 years, and the Eurocode is then comparable with the Eurocodes that we have for other traditional building materials like steel and aluminum and glass. Further, I have listed other national standards that may be relevant for your business area as well. Some of them, most of them are from UK or Holland, but the German ones, the Berufsempfehlung is also very noticeable and very good regarding this area. Now we will get a deeper picture of what we are actually doing here at Fiberline. And as mentioned, one of our biggest business areas is the wind industry. And for the wind industry, we manufacture primarily carbon fiber lamellas, which are used in the production of wind turbine blades. The carbon fiber lamellas can be seen on those 3 images here. They are used in the resin infusion process that is taking part at the wind turbine blade manufacturers. The lamellas are made of carbon fiber and only consist of unidirectional fibers. They are very strong and they're very, very stiff. They are about 3 times stronger as comparable glass fibers. Further than that, we also manufacture root ends for the wind industry. Those can be seen on the image in the middle. They are manufactured out of glass fiber. And other than that, we manufacture several other different products that are used in the wind turbine blades. And next slide shows some different substructures that we also are manufacturing for the wind turbine industry. Primarily, we have manufactured a lot of heli hoists. Those are the red here on the image, yellow hoists that are used for hoisting down a crew that needs to maintain the structures. We have also manufactured a lot of internal platforms, nacelle floors, and platforms in the tower as well, and a lot of boat landing platforms as well. The idea behind this is FRP is lightweight and it does not corrode even on the harshest environments offshore. And here are a few of the images of different products. To the left, you see a mock-up of a nacelle floor. To the right, you see a fiberline heli hoist platform and boat landing platform as well. And some of those structures have been actually offshore for more than 20 years without any need for maintenance. Next few slides will be about our building and construction materials that we manufacture here as well. Those are primarily made of pultruded glass fiber. Like mentioned, we have our second biggest business area are actually wind and window profiles. We manufacture to some of the largest or biggest profile or window manufacturers, primarily in Germany and Switzerland. The profiles can be manufactured totally from pultruded material, but normally we see them mixed with other materials like wood on the image to the left. They are very light, and they do not transfer the heat from outside to inside. So having very good isolation properties, but they are also very strong, so they can easily carry triple glass windows and doors as well. Further than that, you get very slim look from the outside with very thin bezels around your windows. Other application areas are sliding door profiles as well. Again, some of the core features here are that are isolating profiles and does not transmit heat. Facade profiles, we are also very well known for that as well. We manufacture ley light profiles, and this is something for designers and engineers. Ley light is a pultruded cross section with special resin that, when cured, is transparent. You see that very good on the image left. The reinforcement is visible, giving the surface a unique expression, but also making the profile very strong. Two images I have taken here with us is the South End Pier, built in 2011, and our headquarters in Middelfart, built in 2007, where the whole facade cladding system is made of our internal ley light facade elements. Something a bit different, in 2016, Bjarke Ingels designed Serpentine Pavilion, exhibited in Kensington Garden, UK. This pavilion consisted of 2,000 boxes made of pultruded ley light material. The 2,000 boxes were all bonded together, making the construction stand about 14 meters high. Now, something a bit more familiar to me, structural profiles. Here I have divided this in several different application areas, where the first one is cooling towers. Hopefully you can see the small video I have shot here last year of a cooling tower in action. The profiles are submitted or submerged underwater. A lot of them are actually a lot of them are getting water for more or less a year out. The profiles are, the water is up to 80 degrees high, and it's contains a lot of chemicals and that's why the profiles are very specially very good. These profiles are primarily manufactured for this application. Cooling towers are primarily designed in cells. You see actually the bottom image on the right are 4 cells, and you see actually when you remove the cladding, you see how the cells look from the inside. Next slide are stairs. Stairs are also made from our standard cross sections. They can be designed in very different ways, in different spans. But again, here I have taken different slides for you. Both stairs are made in Germany for the German railway industry, and are actually located very near each other. Railway industry also a very big business area. The image to the left is a platform built in 2016 in Latvia, where the construction crew is actually hammering down the standard cross section from fiber line down deep down in the earth, and then bolting U-channels left and right, and after that mounting our standard planks on top as well. So you can actually manufacture whole platform using only fiber line material. Similar platform in Germany as well, you see on the right, and only here it is fitted out with a grading bottom. Bottom image is a small platform made by the company Alexis in the UK as well. Those platforms are mainly used for transformer stations and other smaller maintenance. The swimming pool application is very big area for pultruded, but also in general for composite materials. Here we have several different areas that we normally are active in. The image to the left are movable swimming floors. They can be raised or lowered by the operator of the swimming pools. When children are swimming, they can be lifted up. So, and then when the adults are swimming, they can be put down. Swimming pool dividers as well, also made from standard FRP elements. The image to the right bottom as well. This is the Olympic swimming pool in Odense. Next, one of our biggest areas are bridges. I have taken several different small images on the left. We can manufacture full FRP bridges with the highest traffic construction classes according to Eurocodes, but primarily we are active in smaller foot and bicycle path bridges, which you see on the right. The image on the right is the latest construction that I have been part of, and this is a bridge spanning 6 meters by 3 meters. The whole bridge is about 750 kilos and is designed for vehicle traffic up to 8 tons. The bridge was installed and mounted to the foundation in about 30 minutes by a crew of 3 men. Sustainable production. We at Fiberline are proud to have a sustainable production. We can tell that the electricity used for the pultruding process comes primarily from wind turbines, where we have supplied components to ourselves. And when we look deeper into the process, we see that, for instance, air and water pollutions are very limited when we talk about pultruded profiles here at Fiberline compared with aluminium, steel, and concrete. Further, the CO2 emissions are also very low because the process only requires about between 80 and 250 degrees Celsius for the manufacturing process itself. The main CO2 emission comes actually from the manufacturing of our raw materials. Further, energy consumption is also very low. The reason for this with the very low temperature for the manufacturing. What about recycling? Well, we at Fiberline do a lot of to recycle our scrap on our unused material. We have co-developed this process where we crush the larger elements down to smaller pieces, about 20 centimeters in diameter in length. After that, the crushed profiles are shipped to a cement plant where they're used mainly as fuel, but also raw material in the cement manufacturing. After that, you have your cement, and then you can manufacture tiles, concrete, and so on. By crushing FRP, the cement manufacturers use less coal, but also benefits from the glass reinforcement, which is then a raw material. There's a small figure on the left. By using 1,000 tons of GFRP scrap, they can save about 450 tons of coal. We are also trying to rethink recycling and have recently been in contact with the company from Denmark called Miljøskærme. Translated in English, this is environmental screens. They use the crushed material to pack cassettes and use them as sound barriers. Usually sound barriers today, they contain stone or glass wool, which absorbs the sound. This can easily be replaced by the crushed FRP material as well. This makes this application area very interesting for a lot of other companies. When this webinar has made also awaken your interest in pultruded cross sections, we have sample boxes that you can order today. If you want to get feel or get in touch with Fiberline pultrusion profiles, you can order those sample boxes today and get 50% discount. Sample boxes contain several different cross sections in about 20 centimeters of length. If 20 centimeters is not enough for you, you can also visit our webpage where we have profiles up to 50 meters in length also for order. And I think I will take a few questions now.
Yeah, we have a few questions. How to prevent color fading of profiles with dark color in ISO resin system?
Well, normally we have experimented with pigmentation in our standard resins. The issue is UV will eventually break down the color and the color pigmentation as well. The best way to prevent the fading of a color is to paint them afterwards, or give them a paint coat as well. Regarding I can take one example here. The helihoists that we have delivered for many years now are normally red profiles coming out or gray profiles coming out of the machines, but we coat them or paint them red to ensure that the red color will stay or last a minimum of 20 years.
What are the trends and developments in the pultrusion industry?
Regarding trends, we will probably in the future look towards using more thermoplastic resins because they can easily be recycled. Thermoplastic resins, you can melt the resin and reuse the fibers and reuse the resin. That is not possible with thermoset resins today. The only way to recycle thermoset resins is by the two methods that I have been described today.
Which fastening methods are best suited for pultruded elements?
Normally, we recommend bolting as it's very well known and very documented. But for project applications, we have also made several different videos and instructions on how to bond construction, how to bond FRP to steel, wood, or even concrete as well. So you can use mechanical or chemical fastening depending on your application area and the loads that needs to be transferred.
What is the price difference between GFRP steel and aluminium?
The price difference between GFRP steel and aluminium. Well, FRP, depending on what you are asking for, if you are asking for standard cross sections, for instance, from Fiberline, then we normally say we are cheaper than stainless steel, but more expensive than aluminium. So somewhere there in between, depending on the project size. But it's not just enough to look at the price difference. You need to look at the different possibilities and options that FRP will give you.
Would you talk a bit more about the fire protection?
The fire protection. Well, we mix fire retardants to our resins, which will benefit the overall fire performance. Normally, when we talk about fire performance, we primarily use the EN 13501 classification. The classification is from A to F, F being the most flammable. Our standard cross sections, the certification is dependent on the wall thickness. If you have a wall thickness thicker than 10 millimeters, we can more or less guarantee that you have a classification of C. Below 10 millimeters, you are probably looking at D or E. So fire performance is dependent on the fire protection you put in your resin, but also of the wall thickness that you are actually testing or thinking of using.
Could you please develop in more details what low-profile additives are?
If I can go back a few slides to low-profile additives. We use them in our pultrusion process. They reduce the shrinkage. I cannot tell you what they are probably because even the manufacturers themselves they don't know in detail what they consist of. But they reduce the shrinkage of the profile coming out. So when the profile comes out of the pultrusion line, it's about 90% cured. The rest is actually cured over the next 24 hours. And to reduce the shrinkage and form of cracks, we have to mix low-profile additives, giving the profile more stable cross sections as well.
Yeah, we have another one here. How do you ensure good slip resistance on your pedestrian bridges, stroke platforms?
We do that by means of coating the planks, bridge planks after the manufacturing process. We normally spray a thin layer of polyurethane paint or epoxy paint, and then drizzle that with different kinds of stones or sand. So depending on your project and what kind of slip resistance you need, we have different sand types or different grain sizes as well.
There's another one here. What about connection technology? I think they mean what about connecting technology?
Yes, this will be the part of the next webinar where we'll get a deeper view of how to fasten or connect different elements together. But normally we use standard ISO or DIN bolts for connecting. Further to that, we have also made a lot of we have made it easier for engineers and construction people, where we have predefined some hole distances and on distances to the edges, so we can easily take this up and drill and make and be safe with your connection methods.
How to prevent color fading of dark color profiles? That's good. What sort of software do you use for designing GFRP structures?
Software for designing GFRP structures. Internally, we use software by Autodesk. It's called Nestra. But I know that a lot of other IT systems has more or less the similar softwares for FRP structures.
Is it possible to protrude using natural fibers? And if so, could you give an example, please?
Yes, it is actually very easy to protrude with natural fibers. The problem is that the natural fibers vary much in the properties. Like using hemp or even wheat, you can protrude with natural fibers, and you can also get natural resins as well, so you can have more or less CO2 or zero emission products in the end. The problem is a lot of information that we have with the current resin systems and with glass fibers as well. A lot of information is lacking. So something like how long will this last? This is the main issue here, but I can see when I look 10 years in the future, I can more or less see that the glass will be switched with some kind of natural fibers, but there is a steep learning curve that we have to get started with.
Can a process of customized profiles be envisaged for architectural one-off projects, or is the process feasible price-wise only for mass production?
Well, the process is actually only feasible for mass production. The next slide here, the tooling, the blue element with the fiberline name on it. This tooling is very expensive. We are talking about 20 to almost 100,000 euros for tooling here. So depending on what you describe as mass production, you need to rethink if you can use some of the standard cross section that we have. We are actually today we have more or less more than 1,000 different toolings. Most of them are customer specific, but we have about 100 standard cross sections that a lot of our customers normally use. But the tooling is very expensive. So you need to rethink if your decisions when talking about custom profiles. But yes, everything is possible, even with pultrusion and elements up to 1.2 meters in width and about 500 millimeters in height are actually even are easily pultruded. The only issue is about the volume.
Can PU color pigment be used in ISO resin systems in pultrusion process?
Yes, they can, and we use them also here today. I think this was the last question. Forward.
Please give us some more information about windows manufacturing, such as thermal and mechanical properties, costs, etc.
Window profiles. Well, depending again, the manufacturing is actually very easy, and you see like this window profile. It consists of 3 different profiles. So depending on what you are aiming for, it can be comparable easily with the traditional building materials. Issues here, how you mount the corners. For instance, here you see on the image to the right, the corners are actually the strength of the corners are increased with steel as well. So you have to look at your overall window or door and see if FRP, pultruded FRP, is a solution for you here. But we can forward you some information regarding the mechanical properties, but also the insulating properties of a lot of our window and standard construction profiles as well. And that's it. Stay tuned for our upcoming webinars, where we will we'll take a deeper look at the mechanical properties, but also different quality measurements that we normally do here to ensure the CE marking and a lot of the other certifications that we have on our standard cross sections. Thank you very much.